underscore. All right. Okay, now, not all differential equations are separable. So, for some of these, you can't solve them. Now, they can be solved. I'm sure there's some that cannot be solved. In this class, we only look at first-order separable differential equations. So, they may ask you something about an inseparable differential equation, but they're not going to ask you to solve it because we are not supposed to learn those methods for solving it. They might give you a slope field for a question that's not separable because you could still do a slope field for it, but they're not going to ask you to solve for that solution. So if we look at A, I've got dy over dt equals y plus t. First of all, they're using y's and t's instead of y's and x's. So y and t are our variables, and we need to see if we can separate these. So for sure, the first thing you'd have to do is you would have to multiply by dt. Okay, so that would give us dy equals y plus t dt. Are we going to be able to separate this? Is there a way we could do it?
Just a shot in the dark. Could you factor out a t and dt, divide off the y?
You can't factor a t out of dt. You need to kind of like think about, it's not d times t, it's like a separate variable. So you wouldn't be able to do that. It feels like you should be able to subtract y. But before you would subtract y, the dt would have to be distributed. So you'd have dy equals y dt plus t dt. So then if you try to subtract y, that dt would have to go with it. So now you got like dy minus y dt. And have you separated your variables? You fixed your problem on the right-hand side, but the left-hand side has a t that's not supposed to, a dt that's not supposed to be there. So this one is just a dead end. This is not separable. Okay, let's look at B, see if we can separate it. For all these, first thing you want to do, multiply by dt. Because you need that dt to be over there on the right-hand side. So that's giving us dy equals ty over t plus 1 dt. So, it's almost there. I have a y right here. Can I get rid of that y? Okay, divide by y. I'm going to do it kind of like this. I'm going to multiply by 1 over y, which is the same as dividing by y. Then I would have a y in the bottom and a y in the top. And they would cancel each other out. Because this would be like in parentheses, so those could cancel. So that means I'd have to multiply by 1 over y over here. And so I would have 1 over y dy equals t over t plus 1 dt. Are my variables separated here? They are. This one is separable. So that is one that we could potentially be able to solve. And again, that first step is so important because if you don't get it, then you're not going to get the other parts. I used to have C. I put C here as an example of a non-separable equation. But I was wrong, and it is separable. So you can separate C. Let's see if anybody has an idea. First thing, we do dt on both sides for sure. So we got dy equals e to the t plus plus y dt. The problem with that, if I do that, is that if I do, you might have a problem even before. If I do natural log, I'm doing natural log of e to the t plus y times dt. This is multiplied by dt. So I don't think it can cancel because of that dt over there. And even if it could, it would be like this over here. I would not be able to subtract the dt or the y because it would have to be distributed with that dt, and the dt would end up going with it. So no, that will not get it. Any ideas? Has to do with exponent rules. Can I do that? That's a legal move, right? Now can I separate? Okay, what would I need to do? Divide by e to the y. And I've got dy over e to the y equals e to the t dt. So that one is separable. Although I actually wrote that problem thinking it was not separable, but a couple years back it like hit me that those exponent rules could be applied. So that one's a tricky one. In general, if you find yourself like adding or subtracting something to separate variables, you've probably messed up. You pretty much can only like multiply or divide to separate the variables. Okay, so let's do another problem. We got another example here where we got dy dt instead of dy dx, but that's okay because y and t are our variables over here. So we always want to multiply by dt first, or whatever's in that denominator, because you're not going to be able to do anything with that. So we got dy equals y squared e to the negative t times dt. All right, what would we need to do next? Divide by y squared. And it's difficult to integrate when you have things in the denominator. So in this case, y squared, or dy over y squared, how could I write that so I wouldn't have a fraction? I could write it that way, and if I have 1 over y squared dy, how else could I write that? Y to the negative 2 dy. So I'm going to write it that way because it will be easier to integrate there, and over here I've got e to the negative t dt. So do I have these separated? All x's on one, all y's on one side, all t's on the other. We're good. Both have a dy and a dt. If you don't have those, you're going to be in trouble. They have to be on that side with it. So now you can integrate both sides. And so when I integrate y to the negative 2, I'm going to increase my exponent by 1, so that gives me y to the negative 1. I'm going to divide out front by that negative 1, which will just give me a negative right there. I'm not going to put the plus c on this left-hand side, because as long as you're integrating both sides together, we can just like go ahead and combine those c's together. So I like to put it on the right-hand side instead of the left-hand side. So when I integrate over here, now this one has a tiny little u-du substitution that has to happen here. Because when I integrate e to the t, it is itself, but if you want to write this, you can, but if you want to kind of skip it, you can too. Here, the u would be negative t. So du would be negative 1 dt. which would mean I need a negative with that dt, and that means I'd have to put a negative out front. And so what I'm really doing here is negative integral e to the u du, which when I integrate e to the u, I just get e to the u, but it'll have that. Negative out front, and so that would be negative e to the negative. I'm sorry, it's t, not x. Negative t plus c. So that goes right here. Negative e to the negative t plus c. So, all that stuff that I put in green where I did that like UDU substitution, if you wanted to skip writing that, I think you'd probably get away with it here because it's just a very like small detail. You could kind of do it in your head for that. At this point, technically you're solved. Like that could be the answer. It's going to depend on whether how they leave the answer here. There's a decent chance they are going to solve this one for y. So, and sometimes if it's a free response question, it will say solve the equation so that y equals f of x, like it has to be solved for y. So, so if I want to solve this for y, then negative y to the negative 1, how could I rewrite that? Good. Negative 1 over y equals negative e to the negative t plus c. I can't solve for y when it's in the denominator, so I would need to multiply by y. Make sure you're multiplying this whole expression by y. And so I got negative 1 equals y times negative e to the negative t plus c. And then I would need to divide by that negative e to the negative t plus c. So I'd have negative 1 over, there's a good chance they'd write it this way, c minus e to the negative t equals y. I think this is probably what you're more likely to see like in the back of the book or on answer choices if it's multiple choice. Okay, questions there? These are really almost good review problems because once you separate, you've got two different sides of a function that you're integrating, and you got to remember those rules for integrating whatever you have there. So, all right, let's look at this one. This one looks awful. It's not nearly as bad as it looks. The first thing I would do here is I don't do y primes. I get confused with that notation. So I would do 1 plus x squared dy dx plus 3xy equals 0. All right, we got to get the x's on one side, y's on the other. I said your first step's always to multiply by that denominator. It's actually not on this one. What would you do on this one? Subtract 3xy. Because right now, I can't, like if I do multiply by dx, it's got to get distributed to this. So I'm going to do 1 plus x squared dy dx equals negative 3xy. All right, what do you guys think next? Okay, so we can divide by 1 plus x squared. So dy dx equals negative 3xy over 1 plus x squared. Now it's starting to look a little bit more like the beginning of the other problems that I gave you. What would we need to do now? Now let's multiply by that dx. All right, almost there. I still have a y over here on the right side. How do I get rid of it? Multiply by 1 over y. And so you can write it however you want. I'm going to do 1 over y dy, but it would also be okay to just say dy divided by y right there. Alright, so this one's going to be the most difficult one we've done yet because we got a little bit more extensive integrals on either side, particularly that right-hand side. So I'm separated now, so you got quite a bit of work to get here. Now we're going to integrate. What do I get when I integrate 1 over y dy? It is natural log, because if we try to do it with exponents, it's y to the negative 1, I'll get y to the 0, and I have to do 1 over 0. That doesn't work, right? This is natural log. So I'm going to go back up here. So I'm going to get natural log of the absolute value of y equals, and then I'm actually going to do a little bit more work down here. On the right-hand side, I need to integrate this. How am I going to do that? This has got to be a u du. So I've got the u would be the 1 plus x squared. The u is going to be the denominator. So du would be 2x dx. So this part right here is my u. That negative 3, what should I do with it? Let's just pull it out front so it's out of the way. The x goes over here with the dx, but what does it need with it? A 2, because my du is 2 dx. So I would need to multiply by a 2 right here so that this right here is 2 dx. That could be my du. But if I multiply by 2 on the inside, what have I got to multiply by on the outside? 1/2. Now I've kind of made a mess of that. So what I've really got here is I've got that negative 3 times that 1/2 integral of du over u. What do I get when I integrate du over u? It's another natural log, right? So I've got negative 3/2 natural log absolute value of u. So I'm doing like some side work right here. I'll give you a second before I scroll back up to. All right, so I got negative 3/2 natural log of absolute value of u. U is 1 plus x squared. So up here on the right-hand side, I've got negative 3/2. Natural log of the absolute value of 1 plus x squared. I need something else with it, plus c. Now, technically, you have solved at this point because you don't have any dx's or dy's anymore. You've integrated. But it's unlikely that they are going to leave this as a, it's unlikely that they're going to leave this as a equation like this. They're probably going to solve it for y. So, on the left side, it's pretty easy to see what you got to do. What do you need to do to solve this for y? E to the power. And if you do e to the power over here, that means you're going to need to do e to the power over here. But hold on. Are my natural logs going to cancel out over here? You cannot drop the logs because you got a plus c on the outside of the log. And the negative 3/2. But we could take care of that negative 3/2. Let me actually back up just a second. Because right here, this negative 3/2 is not on the inside of the log. Okay. How could I put it on the inside of the log? Not exactly. There's a log property, which is fresh in my mind because we just did this in pre-cal, but probably less fresh in your mind. It's the exponent. You bring that in as the exponent. So like if you have 2 natural log of x, you could write that as natural log of x squared, like that. So that's the property I'm using here. So I could do natural log absolute value of y equals natural log absolute value of 1 plus x squared to the negative 3/2 plus c. Now, you still can't fix your c problem, but you can fix that negative 3/2. Okay, so now let's do e to the power. But it still doesn't cancel. Not quite yet. It does not cancel because of this plus c over here. Because when you do this, you're raising this whole thing up to you're raising that whole right side up to a power. And that plus c makes it where that e and the natural log don't just cancel because there's something else out there, right? But we can use some log properties here. Okay? Because if I have, or not log properties, exponent properties. If I have, x to the second times x to the third, what do I do to combine those together? Nope. I mean, what do I do to my exponents to combine those together? I add them together. I would have x to the 2 plus 3, which would be x to the 5th, right? So if I have something, let me do another simple example over here. This has nothing to do with the problem. I'm just trying to explain what I'm doing. Like if I had e to the x plus 1, I could write it as e to the x times e to the 1. Correct? So over here, I could write this as e to the natural log of the absolute value of 1 plus x squared to the negative 3/2 times e to the c. Now, whenever I'm doing this part right here, I've got e to a natural log, and there's nothing on the outside, right? Because this c over here has got its own e, right? This is just an expression. Now my e and my natural log cancel. So I'm going to put the e to the c up front here, and then I've got absolute value of 1 plus x squared to the negative 3 halves. Let's think about a couple more things. Okay. E to the c is, or c is an unknown quantity, right? E to an unknown quantity, still another unknown quantity, right? So if I wanted to, and I do want to because I don't like the way it looks, can I just write that as a c? Like it's just an unknown number, right? We don't know what it is. It's not going to matter that we have made it a power of e or not. So I could write it like this with just a capital C. And then that c can be positive or negative, correct? So these absolute value bars right here are much like having like a plus or minus. It means that whatever is inside of it could be positive, and then it wouldn't change at all, or it could be negative, and then you change its sign, right? So absolute value bars act a lot like a plus or minus. So if I have a c right here, do we know if that c is positive or negative? We do not. So I don't really need the absolute value bars here anymore either, because that c could be positive or negative, which would take care of that absolute value, those absolute value bars. So we could write it as c times 1 plus x squared to negative 3 halves. And they might leave it like this. This definitely, like, that's a possibility for an answer choice. They also might do c over the square root of 1 plus x squared cubed. They might write it that way as well, like move it back down to the bottom, change it to a root for that. So either one of these are possibilities for what they'd leave the answer like. They're probably, most of the time on a differential equation FRQ, they tell you it's got to be solved for y. So you could have stopped here. Well, I guess technically you could stop without canceling like your e and your natural log, technically, but if you got to use it anymore, it's really, like, the other thing that you're going to see on a differential equation problem, they usually have you plug an initial condition back in, which we'll look at tomorrow, which is going to be very difficult to do unless you get it to this more simple way. So this feels like crazy, like Ms. Hyatt, how could you ever expect us to do all of that? But what we're going to find is that we get natural logs in these a lot, and the C comes out front as the capital C, and there's going to be like some steps that we start skipping. Today we're just doing this one. Tomorrow when we start doing particular solutions, we'll look at several more where this happens. So it gets to be a lot easier than it is here. And I explained a few steps here that I would not necessarily like show my work on every time as we go forward. So that one is sort of a stretch right now, but should get easier as we go along. Okay, questions? All right, good. We got some time, a little time to work. Your assignments is page 382, and you're going to do 1 through 8. Let me make sure that is the right page. Oh, and I moved desks and chairs, so I'll have the wrong. Let's see, 182. Yes, this should be fine.